Hello everyone, welcome back to JP Science. Today I'm going to give you a step-by-step guide on how to add and subtract two-dimensional vectors using their components. Okay, so here I've listed out the three main steps that we're going to use. I recommend watching my video Master Vector Components for Physics because steps 1 and 3, you're going to need the information from that video to follow along. Okay. All right, so here's our first problem. Let's use each of the three steps to add vector A and vector B, okay? And we'll start with the first step, which is find the magnitude of each vector's x and y component. So here in red, I've drawn the x component and the y component of vector A, and in blue, the x component and the y component of vector B, okay? So let's start out with vector A. Vector A's x component is going to be found by multiplying the magnitude of vector A by the cosine of the angle, okay? So that'll come out to this here, 2√3 units. So that's the x component's magnitude. And then for the y component, we'll do sine of the angle. And so that would give us 2 units, okay? If you're confused on how I did this, like I said, please refer to my previous video where I explained how to find the vector components. Okay, so we have this x component and the y component. Great. Now for vector B, we're going to do the same thing. Okay. So it'll be the x component of vector B is the magnitude of vector B times cosine of the angle, which in this case is 60 degrees. So that would be 6 times 1/2, gives us 3 units. And then the y component would be the magnitude of vector B times sine of the angle, which is sine 60. So sine 60 is going to give us √3/2 multiplied by 6 would be 3√3 units. Okay, so we have the x and y components of both vector A and vector B. Okay, so that's our first step. Okay, now that we've completed step 1, let's go ahead and move on to step 2. And that is to add the x components of vector A and vector B to find the x component of the resultant vector, and to add the y components of vector A and vector B to find the y component of the resultant vector, okay? And to help you visualize this, I've drawn this image here on the right. And as you can see, I drew, using the tip-to-tail method, the vector sum of vector A plus vector B, and that would be this green vector here, which is the resultant vector, okay? And what you'll notice in this image is that for this resultant vector, it also has an x and a y component. And that x and y component of the resultant vector is the sum of the components of our vector A and vector B. And so for the x component of the resultant vector, we add the x component of vector A to the x component of vector B. And for the resultant vector's y component, we add the the y component of vector A to the y component of vector B, okay? And so that's where we get these equations right here, okay? Now, since we're adding the vectors, it's going to be a plus sign, but if we were subtracting the vectors, then you would obviously put a minus sign, okay? And we'll do an example of that a little bit later. So real quick, we'll do this. Rx is equal to 2√3 plus 3, and Ry is equal to 2 plus 3√3. And so this, you can approximate it to be 6.464 units and 7.196 units, okay? So that's step 2. Let's go ahead and move on to step 3. Step 3 is to use the components of the resultant vector that we just found to find the resultant vector's magnitude and direction. So if you watched my last video, you'll know that we have this set of equations right here that's going to help us do that, okay? And so first, let's find the magnitude of the resultant vector using its components. And so we would just do the square root of 6.464 squared plus 7.196 squared, and this would give us 9.673 units, and the angle, so the direction, would be the inverse tangent of the magnitude of the y component over the magnitude of the x component. And that gives us 48.1 degrees. Okay, and so what that means is that our resultant vector, which is the vector sum of vector A and vector B, has a magnitude of 9.673 units, and our direction is going to be 48.1 degrees above the horizontal. Okay, so I don't want this video to be too long, so I think I'm going to end it here, but I'll preview the next video. So in part 2, we're going to work with these two vectors, and I'm going to show you how to add them, and then we're going to do an example where we subtract as well.